All right, should we start? So, as usual, I'm going to be going through what is Mobility Helsinki. So, we are really based on the Helsinki city strategy, where the strategy outlines that Helsinki actively cooperates with universities and businesses in research and innovation projects. And also, Helsinki must be an enticing place for testing out new solutions in urban environment. So that's sort of the background. And Mobility Lab Helsinki, we are one of the test beds of the city of Helsinki, or Business Helsinki, together with education technologies, built environment, circular economy, and health and well-being. So we serve as the smart mobility test bed in Helsinki. Quickly about the objectives. So the first one, ecosystem. What does this mean? This is collaboration with different stakeholders, like today, the development and innovation communities, and of course, creating new projects and pilots. Digital twin, this has sort of been a big topic in our agile pilots in the past 2-3 years. So it means developing tools for mobility digital twin. And lastly, testbed activities, so enabling and supporting testing and developing of companies their new smart mobility solutions in real urban environment in Helsinki with actual users, that being the residents of Helsinki. Okay, the objective really from the economic development point of view is to support the company's research, development and innovation activities and growth, supporting the creation of new businesses, and also producing better services for the city and residents. And this is actually done by utilizing city resources, infrastructure, buildings, street environment, procurements, investments, and so on. You can go and see more at testbed.hel.fi. All right, now as we have rushed through what Mobility Lab is, I'm going to go deeper into the AI in Mobility Challenge. So together with Finnish AI region, FAIR, we invited companies to utilize new technologies. We wanted to see what kind of solutions the companies have to offer for data-driven management and better resident participation by using Helsinki-related mobility datasets. I will quickly talk about this later on. The process in the Mobility Challenge was a bit different what is usual for us in Mobility Lab. So we actually had an open call for solutions, open for everyone. Then we selected 10 of these solutions. Then with these companies and solutions, we had an expert day and business coaching, 1 full day of business coaching. And yeah, after that, the companies actually honed in on the solutions, and we had a demo day and pitching. And from that pitching, we, Mobility Lab Helsinki, we chose 2 pilots to actual agile piloting. And this was done by using the metric of how impactful is the solution, is it feasible, and it has to be innovative. So these 3 metrics. So 8 companies participated in the demo day in total, and the pilots chosen, yeah, we're going to talk about them later on. Yeah, the themes of the challenge were functionality, safety, and sustainability. We didn't want to narrow it down too much, but here are some examples what we were probably expecting. But importantly, we wanted to highlight the use of artificial intelligence, supercomputing, and VR, AR, and XR solutions. And importantly for us and our project, of course, available data. So we wanted the companies to actually explore the data sets, some of the data sets, even data from our previous pilots, data from Mobility Data Catalog built by us, Helsinki-specific data from Helsinki region InfoShare, but also the companies can use their own data. So that was the requirement. And yeah, I guess now we are going to hear more what the companies have achieved in a relatively short time. I think we had 1 month and 2 weeks for the solutions, right?
Yeah, it was a very short amount of time for the companies to develop their solutions, especially because both of them started kind of from the scratch. So I think without further ado,
Yep.
I think we can introduce our first company, Cadweiser, and their solution, Traffic Info. So I would like to ask Nestori Lautanala to present their solution. Welcome.
Lovely. Thanks for inviting me. Yeah. As you heard, my name is Nestori Lautanala. I've been working with Cadweiser a little bit with this solution, and what we really came up with was this idea that you can use data that we have in our society to really show how efficient the traffic is, and portray these traffic related messages for various audiences, and do that in multiple languages, make them more accessible, inclusive, by using LLMs to decipher and synthesize these messages. So what we did was, in a nutshell, we created a service from scratch that uses various kinds of data sets, real-time APIs that we plug into our service, and that way, as you can see in the picture, shows how smooth the traffic in Helsinki area is. And in addition to that, we did some user testing. We did a survey to see whether this is a problem that the citizens of Helsinki really do face, and if it is something that really warrants some more future work in this area. And we tried to identify a product market fit, but ultimately the result is that we need to still modify our service offering and really hone in on what we really want to achieve with the solution. Yeah. So our really, in a nutshell, our goal of the pilot was really to do the data delivery in a timely, very effective, and easy to understand manner. So there's a bunch of people who in Helsinki who might not speak Finnish or English as fluently as one like. So we created this service that shows, I think, 40 plus languages, all the traffic related messages that we have from FinTraffic, and really provides this information in multiple modalities. So it's both written, it's pictures, and then it's also we're able to create these audio messages based on the data. And to be honest, I think it works really, really super well. And our solution is actually quite simple. So we connect to the multiple data sources, traffic incidents, weather data, road conditions from FinTraffic and various other sources. We parse the data that we get, and we let the LLM synthesize this information into the messages. We generate the audio and then distribute these messages in various formats. Our initial thought was that we would really want to serve this solution to radio stations who would show or play these messages, audio messages, to their listeners. And in for example, in our user testing, we identified that actually a lot of people, as you might have also already guessed, use radio to listen to these audio incident reports and whatnot. So this is a really good medium for giving this information to the people. But ultimately, the interest was a bit lackluster, so we didn't really manage to go down that route so much. Yeah, here's our implementation. Super simple stuff. Overall, based on around Herakku and a few database instances, and then we plug everything in and show it on our web application. And I think in the end we can really dive deeper into our application and what it is capable of doing. But really, as I already told, we did the key activities, designed and tested the demo from scratch, and this really proved to be quite fruitful. So at least we learned that using these AI tools is actually quite simple if you just manage to put in the work and really use it as well as it possibly can. We did a lot of feedback from various industry experts, and there also the message was that it's a nice to have solution, but we didn't really feel like we got a true product market fit for our solution, even though it works quite well. But there really is a gap between user needs and what people are willing to pay. So maybe perhaps in some future scenario, there might be a solution, a public solution that really comprises or comprises of all these data sets that we have. But I think as a clear next step, we need to reevaluate a bit our solution and the positioning we have. Yeah, maybe it's a good time to test our solution a bit. So this is actually 3-minute-old data from all around Helsinki. So these are all the big routes in Helsinki region, Espoo, Vantaa, etc. And here the dark green shows that all the traffic is smooth, and there's no real incidents apart from a few spots. So for example, at Kehä 1 going eastwards, there's some it's a bit queued up, and then for Itäväylä, so from Kulosaari or Kalasatama to Itäkeskus, it's a bit queued up as well. But this really, I think, highlights our sort of key finding and which is that Helsinki really is not a big enough city to have truly large scale issues with the traffic and mobility. So apart from rush hour times between, let's say, 8 and 9 a.m. and 4:30 and 5:30, there really isn't an issue. And this is, when you think about it yourself, you do realize that actually, traveling with public transport and traveling with, all kinds of other vehicles is quite smooth in Helsinki, which I think is a phenomenal thing. Yeah, and then as you can see, there's been a couple traffic, traffic reports. So there's one in Lohja. So there's been a traffic accident. It's like 25 minutes old. So we all get all the data, and if we want, we can even create a voice. A voice in, let's do it actually in English, maybe it's nicer. So yeah, traffic announcement in Lohja. So there's been a report of accident between Karja and Lohja. And then if we can perhaps listen to it, see if we hear the voice. We don't, that's fine. But yeah, so you're able to use all these kinds of technologies to really make these make all the data that we have in our society, make it sort of touchable. You can feel it. You can get insights from it, and I think that is something quite good. Yeah, I think now's a good time for perhaps some questions.
Thank you, Nestori. Let's give a bit of an applaud for this. So, do we have any questions from the audience? Because there is a microphone that we can give to the audience. And of course, if anyone in the online environment has some questions, then we can take it from there. And if not, let's start with one question from my side. So could you please elaborate a bit more, like what kind of sparked this idea of this type of like traffic info solution?
Yeah, I think that's a really good question. I think this was something that we identified in a few discussions, and the sort of idea came more from FinTraffic side, that actually this might be something quite useful and something that should be perhaps demoed. And I feel like it really all came down to the fact that there's this feeling that there is so much data all around us. There's different kinds of APIs. There's even discussion whether all these APIs should be open for anyone in the public to use. Perhaps some should not. Some critical info perhaps should not be shared, but nevertheless, it's out of the box now. So it's available for everyone. And with this kind of traffic insights, it really came down to like developing a view that, okay, maybe this is something that we can play with around a little bit. And we did a couple, super short demos using LLMs, not in this level. And we sort of came up with the idea that actually, or came up with the conclusion that this actually works quite well. Parsing all kinds of different data from various sources is a really fruitful use case for any kind of LLM. And there we pitched the solution and luckily got selected, and now we're here.
That was a really nice answer. Another question that I would like to present is that we already had a discussion that the user testing didn't bring as many not native Finnish speakers as we would have wanted to achieve. But when we first had this initial discussions regarding this application, its use cases, it was quite clear that it would probably give like extra benefit for people who are not native Finnish speaker. How do you see this? Would this type of demographic maybe be something that you could be targeting in the future?
Absolutely, perhaps. There's a lot of people in Finland, in Helsinki especially, who don't speak Finnish as a native language, and thus might not be, able to receive all these kinds of traffic-related reports and messages from various, both public and private sources. So I think this kind of LLM capability in all these services of being able to accurately translate real-time data into personalized content, that would be a phenomenal thing. Even though I think it would really have a magnificent, super good impact. Making this insights about how the traffic is flowing and what kind of movement services you can use more accessible to various kinds of people. I think that's a really positive thing and something that should be looked into a lot more deeply.
Thank you. Do we have any more questions from the audience?
You can probably hear me from here anyway, but yeah, I was just wondering, have you done kind of any demographic research into what the crossover could be between non-native speakers and drivers, and like whether there are any particular groups who might find that useful? Because it strikes me as I'm a non-native Finnish speaker. My two friends here are also, but we're students and we don't drive.
Yeah.
And do you think there's a correlation there at all between maybe people who aren't native Finnish speakers and people who don't have cars because they've moved here without one and don't need one because the public transport is good? So I don't know.
No, absolutely. I think in general, for example, there's a big student population in Finland who are not native Finnish speakers, and especially in the south of Finland. So I think these, improving the local bus services, the HSL application and whatnot, that should be a really like a clear goal of making it more accessible and making this data more available. But as to come back to your question, I think it's true. It really is true that there might not be so many people who are not native speakers of Finnish and do drive a car on a regular basis. Although, of course, it really comes down to car ownership and whatnot, and who has access to these things. But I think overall our data gathering was not so large enough. We didn't really get a large enough sample to really have a super deep dive view into it. Although we did look into a few really recent data sets from FinTraffic, which have over 1,000 respondents with various languages and languages spoken and various age demographics. And I think there it really shows a sort of a view that actually people who are a bit older might not necessarily have the tendency to use these digital services as much, and thus they weren't really we couldn't really target them as well, versus people who are slightly younger. They prove to be a bit easier to target with our service.
We still have a little bit of time for questions if someone has something. But if not, then I would like to ask just one more question. If you would like to share a message for anyone who will be piloting in the future, what was your experience doing this AI mobility challenge this autumn?
I think the experience was quite good. I think when you're working with any kind of LLM solution, there's a few things that should be really thought of. I think number one would be to really construct the solution in a scalable way, and in a way where you can plug and play and add modules and work in a modular way, because this really future-proofs the solution and future-proofs the demo, even though it might be a bit more work initially. So, for example, our solution, we could change the LLM we're using, but for us, it makes sense to use what we're using. Another thing that I would highly recommend is gather the user feedback. That really proves helpful when you're making the solution better. And the third thing is super rapid iteration. Like, you need to constantly make changes and constantly make it better. I think that really proves to be a useful recipe for a successful pilot.
Thank you so much. I think then we can move on to the next pilot. So thank you, Nestori and Cadweiser. So the next one is Hiroshi and his team of NinjaLABO. So welcome. Yes, I think you can start. And then we can change the slideshow. Yes.
Hello, everyone. Our project is no-code vision LLM. So at first, who we are. So NinjaLABO is a quite fresh Finnish startup, and we are really small. So we originally focused on quite small thing, which is making big AI to small, and to enable the AI running on a variety of devices. And we are funded by European Space Agency, and we are trying to put the AI running on satellite. That's our thing. But this time, we tried to make some really end-to-end service. And this project is LLM CAN, so which means that the AI is interacting with the camera. And recent LLM, it's multimodal, so it can communicate. It can withdraw quite many of insight from the what it can see. Like on the right side, you can see there are it can identify traffic jams, traffic accident, and some kind of criminal activities and parking spaces and waiting queue of the restaurants, or any temperature or anything. And it really understands quite many things. Then that's why we thought it's going to be quite useful service can be generated. So today we are going to make 3 demos as written here, and it's already published in YouTube site as well. But now I'm passing to the link for the first use case.
So hello, for our first demo today, it will be about the parking lot monitoring.
Do you want to the video? Or,
Yeah, maybe the video, because I think you can type it. Yeah, video.
Video.
Yeah. So we have pre-recorded the scenario. Yeah, thank you. So as you can see here, this is our demo for monitoring the car parking. So first, we will give the video live link to the LM Cam chatbot and ask it about the situation inside the video. Yeah, so as you can see here, it will provide us several information about the quantitative. So for example, we can see that there's one car in the scene and many of the street lights. And also it is also state that like there are many available parking spaces, for example, here 10. And now I will ask it more about like how, for example, like the traffic. Is it heavy now? And it says that it is not heavy, it's quite light and there's not many cars. And next thing I will ask it about like, what do you think of like how can we park here? How easy is it to park in this area? Yes, so based on the information gathered from the live, the LM cam can detect that there are not many cars and there are a lot of space and there are not many traffic either. So the parking process will quite be straightforward and easy. And this is one of our feature for LMCam is the notification. So if I ask LMCam to stop the notification stream and ask, for example, notify me when there are 5 or less cars in the live, then it will start monitoring the video, the link that I provided. And then when it detected that there are fewer than 5 cars, then it will send us the notification. So that would be the first demo scenario for the car parking. And now I will switch to the second demo for how to integrate the OS into LLCam. And I will switch the mic to Nghi, who will be in charge of this demo.
Hello, so my name is Guy and I'll be demonstrating one of our use cases. So this is our actual website. It's deployed at llcam.ninja.labo.ai. And we can see from this side, we have the available tool list. And this is, again, hard-coded into our program. However, a special feature of like our service is actually to integrate new services on the fly into these available tools. So this demo is also available here. Dynamic service loading with DG traffic. And I'm going to use this as a kind of like command prompt for our actual demo here. So now I'm gonna start with asking. So I'm asking what tools can you use into the chatbot? And it's going to answer based on the available tool list right here. So it says like camera and image tools, which are demonstrated in the previous demo. And then it also have plotting tools. And here's the tools that we're going to use, which is API tools. So now I'm going to ask a kind of like tricky question. So I'm asking, based on these tools, can you tell me where there are traffic jams currently? So it says that to determine, it's going to capture but to find location of traffic cameras and access traffic conditions. However, this is only usable if we have a specific camera in mind. So instead of using these kind of default tools, I will add new tools to this service. So the service that I'm integrating is DG Traffic, which is a very open service with the open SBI specification. So I'm going to like copy this command right here. So as you can see here, I'm providing GPT with the base URL, and then I also provide the open API specification URL, which is yes, I'm adding it back here. Yes, I send it like this, and then after a while, it's integrating. And now it says the new service has been successfully added. And you can see from this side, the available tool list has expanded. And all of these newly added tools are endpoints from DG traffic. And now I can actually use that to determine where there are traffic jams right now. Yes, so it's actually extracting, communicating with D2 traffic, and now it has extracted for us our traffic disruptions and jams. So we can actually again use our default service in combination with this or any further services that are available from raw D2 traffic. So this is how we can easily integrate, and the user side can also easily integrate any URL or any API services that they want to on the fly like this. Yes, and I'll go back to Lynn for the last demo. Oh, yes. Not exactly, but you can actually use, I think this one is, yeah. Yes. So now it's just the reason that it's not exactly the same is because we have not really implement the road into this yet. So this is just some random road in the same area, but this is actually one of our default tools. So this demonstrates that you can combine different services and tools that are integrated into this session right here with our service. Yes. So I'm going to go back to Lynn.
So thank you, Nhi, for the second demo scenario. And now I will proceed to the third one, where we will feature the ability to count objects and also plotting objects. I will use this, not this one, wait, maybe this one here. So here, this might be easier to see. So this is the live demo, live YouTube at Santa Claus Village, which is this video was recording this morning, so there were quite a lot of people. I asked GPT again to capture the situation at the village. Yeah, so now that, because this is a scene with a lot of people, so it can detect that there are quite some people. So here it says that there are 50%. And it says that there are like daylight, and also the vision is clear, but the sky is not really visible in the frame, for example. And in our default tool, there are two tools that can use to count the objects. One is the GPT, which is the default thing that the LLCam is using. But the second thing is that the YOLO, which is a computer vision model used for object detection. So as I say that, can you show me the detection image? I'm referring to the YOLO model. And now that the LLCam can show you the detection image of what it detected. So YOLO is not very good at detecting a crown. So GPT might be better at least say that there are like 50 people here. But if there are like spots seen like fewer people, then maybe YOLO will provide you with more accurate and like kind of like bounding boxes around the objects that it detected. So now we will proceed to how LLCam can implement the plotting feature of object counting. So first, I will ask it about the images that it had captured at Santa Claus Village during yesterday and today. It will show a list of image here, but there might be some kind of like errors. So I stated again. I stated that I only want the image at Santa Claus Villages. Yep. So these things, this time is more accurate now with like 4 images of Santa Claus and still one non Santa Claus, but it's better. So now I'm asking it to plot the number of people in these images using YOLO. So it will generate a bar plot here stating the number of people in these images, which YOLO can detect. And now the second time I will ask it to use both YOLO and GPT, and it will generate a plot with 2 bar plots, one for GPT and one for YOLO to compare between how different models will perform on the same list of images. So here's our result that you can see here. For the blue one is the YOLO, and for the red one, I can stop. Sorry. Here, so for the red one is the GPT. It might be a bit blurry on the screen, and the right one from my side, the blue one is the YOLO. As you can see here, YOLO will be more accurate on the scene where like there aren't that many crowd, there aren't many people. But for like a very crowded scene, like the current situation at the Santa Claus Village, then GPT might have a like broader sense of view, and it can provide us with more accurate on this kind of scene. And so that will be our third demo scenario for the ability to capture live and plotting and detect object. Yes, thank you.
So then going back to the wrap up. So what we have learned from this project is kind of brutally say we can consider web development or any service development can be considered as a API mashup. So primitive APIs are already quite many places are provided, like digital traffic. So you can use those primitive API, and web development is the mashing up those API to generate new services. That's how it should be done, has been done, like from primitive to the complicated. And now with the power of AI or large language model or GPT, this API mashup part could be done almost out of box automatically. So we don't do anything, just giving the API specification, then the rest of the service gonna be done automatically by GPT. So that's really our finding. And if we extend this idea iteratively, then what happens is what people are talking about AI agents now, like from primitive APIs are generating more complicated services. And if we iterate this kind of things enormously, then your instruction gonna be quite high level. Like this is a bit joke, but if you instruct that make this world peaceful, then the GPT will understand and it will distribute the task, and it's iterate towards the really the primitive ones, and it's going to be orchestrated. So that's the world we are living in the AI agent. So really, how can I say, exponentially scalable, but there's no silver bullet. So always it comes with the challenges. So what we found is the 3 challenges. One is imperfection of natural language communication, because it's not programming language. There are some rooms to be misunderstood. And also the scalability of the computing resources. And if one GPT, one large language model has the millions of API, then it's easily got confused to pick up the right one. So it cannot achieve the original instructions. And also the one is the learnability. So if the instruction fails, your request fails, GPT has to be learned and customized and optimized for the next things. Those are the challenges we have to be solved to proceed with next step. Yep, that's all what we have.
Thank you so much. Let's give a round of applause. I have to say that I'm amazed how great work you've been able to produce during this short amount of time, and I know that you've been quite stressed about it too. But I have to admit that it's brilliant. Do we have any questions already in the audience or in the online? If not, then let me start by asking my own questions. So the first thing is to ask, what are your next steps? How do you see the future of this type of service now?
Yeah, actually, we quite stressed, as you said, because of the short development time, and this is not our original area, but we really enjoyed, and we quite learned a lot, many things, and also now we understand what the AI agent means to the future, and we really want to continue this project, and we are really looking for the sponsor or any project to be hosted these technologies. And this technology is not limited for anything, but could be applied for the smart city services or smart building services, and even it could be extended to the robotics as well. For example, if you think about the practical use cases, then queuing, waiting queue detection for the restaurants or public services like Kela, those kind of services, or we can identify also the safetiness of the playground. So if some kind of risky criminal people are there, then it could be even detected. So the possibility is quite enormous, and we really looking for the sponsor for this project.
could it maybe generate even like a trend report in the future, because it can capture moment by moment? So is it also a possibility in the future?
Yeah, that's easily done, as Lynn demonstrated.
Yes, exactly. Any other use cases that you would be interested in trying out, or have you already got any requests from anyone that?
Yeah.
Not yet.
I
Okay.
think personally, I really want to go to the robotics with this, because the principle is exactly the same.
Okay, that's very fascinating. Any other questions from the audience? There is one.
Thank you for a good presentation. You mentioned robotics. So how far you believe currently that the edge processing of the large language models are, so we could have this local AI?
Yeah, that's exactly our competence. We started, but this time we didn't have a time to do that. But it's really the area we really want, and the situation is still a bit experimental. But the computing environment is getting better and better for energy saving perspective as well, and also the technique how to make the big AI model to smaller, that's also progressing. So I think exactly it's a time to dive into that direction.
Thank you.
Thank you. And then maybe one more question from my side. It's the same question that I presented to Cadweiser too. So what are your experiences from this piloting phase that you were executing during this autumn? And is there any message that you would like to send for someone who is thinking about participating into this type of pilot in the future?
I really respect that you accept this kind of bit advanced proposal, and personally I really enjoyed, and probably they have some words.
I think I really appreciate this experience working with my team, and especially I really like this concept of like dynamic integration and then complex. As you can see, we actually do very complex operations in the background, but then when we present everything to the user, it's very simple, it's very accessible, and that's like the journey of making like those complex into like simple use case. End-to-end experience is quite a learning experience for me, and I really appreciate this opportunity.
So before working with this project, I am not very familiar with LM, but then I think that like it has a very large like potential to be integrated in many aspects of life. So as you can see here, like it can talk with people, like communicate using natural language and understanding our context and know where it can improve. So I think that is very fascinating. Now we can communicate with machines and tell it to learn more, and it can also help us to experience, like know more about the situation outside without us need to explicitly tell it to search for like things online. That is from my side.
Thank you so much. It's been a pleasure working with you all. Also, Cadweiser. I think that's a wrap from the pilot side, so I could ask Jussi to come to the stage and let's talk a bit about our future steps in Mobility Lab Helsinki. Let's give a round of applause for both of the pilots. Thank you.
Yes, really cool solutions.
Yes,
it was fun to be watching the show there. And yeah, this is the actual last event of Mobility Lab this year. And the project has been going on since 2022. And we are also approaching the end of Mobility Lab as a project as it is. But testbed activities are not going to go anywhere because, yeah, what's happening next? So a project called Solmu. So future testbed activities, they will be including mobility hubs and related services to these hubs. So we're going to be taking the same idea of testing solutions in real urban environments, but this time concentrating on mobility hubs. So areas where you might already have services, maybe there is something more to be added, or even single tram stations or areas where a lot of people pass by, but there are not any mobility services for you to go the last mile, let's say. So this is something that's going to be starting in the beginning of the year. So in early 2025, so yeah, in a month. That's funny to say. So there will be an opportunity to also provide input on key considerations about mobility hubs and also help us identify the suitable locations for testing new solutions. And then starting in summer 2025, the first pilots will then begin in these mobility hubs. So stay tuned. I should have had, oh yeah, there it is. So I will be continuing with the Solmu project together. Of course, Business Helsinki will be coordinating the project, and we will be working with the city of Espoo as well. So us three. And yeah, this is the last slide. So any questions related to today's event, you can contact me or Juho Kostiainen, and also related to Solmu and the future testbed activities, you can contact me. And lastly, but importantly, I think in around 5 minutes, you will receive a survey. And we want to ask you how we did today. Did you find the conversations interesting and the event and so on? So please check your email in about 4.5 minutes and answer the survey. And yeah, I think, Satu, it's time to wish very peaceful upcoming Independence Day and yeah.
And Christmas time.
And Christmas. Okay, thank you.
Thank you everyone for attending.
Bye-bye.
Thank you.